Hi everyone. So let's look at page number 4. Suppose you want your fitness tracking app to give users the ability to log food. Once food has logged, users should be able to go back and see what they ate at a specific meal. Write a function that takes a string parameter where you will pass in either breakfast, lunch, or dinner. The function should then return the meal object associated with that meal, or return nil if the user hasn't logged that meal yet. Note that a meal object and the dictionary meals represents the meal log have been created for you below. Call the function once or twice, I think that's a typo, once or twice and print the value, the return value. Okay, so let's have a look at it. So they've created a struct called meal for us, and it's got two variables, two attributes here. One food, which is an array of strings, and the other calories of type int. And they've got a dictionary here that's of type string and of type meal, which is the struct. And the string is breakfast, and type meal has been initialized to say food has these foods for breakfast, obviously, because that's the key, and calories of 530. So let's see, what do they want us to do here? It says write a function that takes in a string parameter. Okay, we could do that. Func, we're gonna call it, I don't know, meal info, I guess. And it said, write a function that takes a string parameter where you will pass either breakfast or the function should then return a meal object. Okay, so function meal info, it's gonna take in a string, let's call it my meal, of type string, right? That's what they want us to do. And it's going to return a meal object, right, of type optional, and or return null, so it has to be optional. Note that the meal object dictionary meals representing the meal log have been created for you below. Call the function, okay, what are we returning here? And return the meal object associated with the meal. So we're returning meals, which is the dictionary, and we're returning my meal, which is the string. So the string is the key, and it's going to return the meal associated with this. I think that's pretty much it. This should work. Great. And then set printed once or twice. So this dictionary only has breakfast, it doesn't have lunch or dinner, but check this out. So if I go print, and inside the print function, we're going to call meal info, which is my function that I just created, and it takes string. And if I type in breakfast, it should return this whole thing. Give it a second. Let's go ahead and run it. It should return type optional, bagel, orange juice, egg whites, calories, 530. If I type in something that doesn't exist yet, like lunch, because it's not in here, it should return nil, and it does return nil. Beautiful. Okay, I have this on manual just because Playground sometimes crashes a lot while I'm recording, so I just have it on manual for now. All right, second question. iOS comes with a few different APIs for persistence or saving data. You'll learn more about persistence in another lesson, but for now, imagine what an app experience would be like if every time you open the app, all of your data was gone. That would be frustrating, right? Obviously. Write a function that will check to see if your meal log, a dictionary like that in the previous exercise, is saved on the device. If it is, return the meal log. If it isn't, return an empty dictionary of type string any. The code you should use in this exercise for receiving something saved to the device is user defaults standard.dictionary, for key, and meal log is our key. So if you don't understand what this is, user defaults essentially saves integer strings, arrays, or dictionaries into the info.plist on the Xcode project, and it's really handy for persisting data or saving data onto the storage for, whatever you're in a game, like your lives or your score or whatever, so that every time you relaunch the app, you don't start from scratch, you kind of resume wherever you left off. I actually have 2 videos on this on my channel, that shows you how to use user defaults. That's standard for persistent data in actual applications. So let's continue here. This code will return an optional string any. If it returns a value, that is your meal log. If it returns nil, then no meal log has been saved. Call the function and print the return value. This might be tricky if you don't know user defaults that's standard, but I'll show you how easy it is actually. It's not as hard as you think. So check this out. I'm gonna create a func. Let's call it get saved info, for example. Oh. And we're gonna, it's obviously gonna return a value here. It's gonna return, what did it say it's gonna return? It's gonna return string any, boom, just like that. And let's go ahead and write closure expressions unused, of course. There we go. Sometimes you forget how to write a function. That's okay. Okay, and it's a simple if let for saving data. So if let, I'm gonna call this, I don't know, my saved info, whatever, right? You could call it anything you want. Equals user default dot standard dot dictionary for key, and this takes a string. You could put anything for your key. It's telling us to put the key as meal log. You could put XYZ for all you care. The trick is if whatever this key is, you're gonna use this exact same string key to retrieve the data when you load it. And we're gonna return my saved info. All right. So essentially here, this is an if let statement. We're saying, listen, go to the user defaults and check out this saved info with the key meal log. If there's anything in here, put it in my saved info, and then return my saved info. Else return. It says else return. The code will return optional string any if the return value if it return a value, that is your meal log. If it returns nil, then there's no nil. Okay, so how do we return nil? We just return an empty dictionary, and that's essentially nil because we're returning a dictionary, and this is just an empty dictionary. And that's pretty much it, to be honest. That's how I would do it, right? Again, not really a useful example if you're not aware of how to use user defaults properly, but that's how I would do it. All right, let's move on. Okay, page 5. Create a computer struct with two properties, RAM and year manufacturer, where both parameters are type int. Create a failable initializer that will only create an instance of computer if RAM is greater than 0 and if manufacturer is greater than 170 and less than 2017. All right, pretty easy. So struct computer. All right, we've created the struct, and it's set two variables, var RAM, and RAM it said is of type int, okay, and var year manufactured of type int. Awesome. And now we're gonna create a failable initializer. So if you've done initializers before, we don't put the question mark, but this is like an optional initializer. It's called a failable initializer. So sometimes it'll initialize, sometimes it won't. So we're gonna pass in two variables, RAM and year manufactured. Okay, of type int as well. And we're gonna say if RAM is greater than 0 and year manufactured is greater than 1970 and year manufactured is less than 2017, and only if all these three conditions are met, self.ram equals RAM self, and again I'm choosing here the self dot year manufactured, the variable, equal year manufactured, the L, which is referring to this thing here, this parameter. Cool. So that's if it initializes. Else, okay, else, right here, else we're gonna return nil, right? So it'll fail. So this will not fail, this will fail, and that's pretty much it. And yeah, that should work. All right, create two instances of computer, optional computer, using a failable initializer. One instance should use values that will have a value. I'm gonna go ahead and do this. One instance should use values that will have a value with the optional, and the other should result in nil. Use if-let syntax to unwrap each of the computer optional objects and print the RAM and year manufacturer if the optional contains a value. So this is really easy. Okay, so all we're doing here is we're creating two values. Okay, rather two objects. So I'm gonna call this loser computer. So this I'm gonna make fail is of type computer. Okay, and we're gonna initialize it, and we're gonna give it a RAM of 0, and I don't know, 1955 is the year manufactured, because this is gonna fail. And I'm gonna go ahead and make this automatic so you guys see what's happening here. If let temp computer, right? So we're using optional binding here, and if let statement equals loser computer, then print temp computer dot RAM, print temp computer dot year manufacturer. And here it shouldn't really print anything. Why? Because this thing failed. This never executed. Why? Because it's saying if RAM is greater than 0. Well, boom, right there, we failed. RAM is not greater than 0. Okay, now let's make another object, and this one will not fail the initializer. Let's call this winner computer, and we're gonna make it of type computer, and we're gonna initialize it RAM 16 gigs and 2016. Cool. And we're gonna do a simple if-let temp computer, I'm gonna call it temp computer 2 equals winner computer, and print a temp computer 2 dot RAM, print temp computer 2 dot year manufactured. So this initializer will not fail because it meets the conditions, and it should print out the two, the RAM and the year manufacturer, 16 and 2016. So pretty simple stuff. So we've got a failable initializer that might initialize, that might not, based on some conditions. So this doesn't meet the conditions, but this does. Therefore, this initializes and everything works. Here it prints nothing because it never even initialized. All right, last page, moving on, page 5. Okay, awesome, page 6. Okay, so long little description here. Have you ever accidentally tapped a button in an app? It's fairly common. In your fitness tracking app, you decide that if a user accidentally taps a button to start a workout and then ends the workout within 10 seconds, you simply don't want to create the log and log the workout. Otherwise, the user would have to go delete the workout from the log. Create workout struct that has property start time and end time of time double. Dates are difficult to work with, so you'll be using doubles to represent a number of seconds since midnight, i.e. 28,800 would represent 28,800 seconds, which is exactly 8 hours, so the start time is 8 a.m. Write a failable initializer that takes parameters for your start and end time, and then check to see if there are fewer than 10 seconds apart. If they are, your initializer should fail. Otherwise, they should set the properties accordingly. All right, that was a mouthful. Pretty easy thing. I know exactly what they're asking for. So struct, we're gonna create struct workout, and we're gonna have var start time, and start time is gonna be of type double, and var end time, which is of type double, just like they asked us to do. And then we're gonna create a failable initializer, and it's gonna take start time of type double, and it's going to take end time of type double, and we're going to do a simple check. If end time is if end time minus start time, all right, if end time minus start time is less than 10, then what we're going to do is we're going to return nil, right? However, else, if it isn't less than 10 and the difference is like greater than 10, so they actually worked out, we're going to go self, I misspelled else, self dot start time equals start time, and self dot end time equal end time. And that's pretty much it. So this struct here, what it's doing is, so we created a workout time, has end time and start time, and this is a failable initializer that takes in start time, end time. And what we take here, the start time and end time, we do a little check. We take the end time and we subtract it by start time. And whatever the result is, if that result is less than 10 seconds, then we say, listen, that was tapped by accident, it's less than 10 seconds, go ahead and return nil. However, if the time difference is more than 10 seconds, it's probably a workout. And therefore, go ahead and actually initialize it. Cool. Try to initialize 2 instances of workout, of a workout object, and print each of them. One of them should not be initialized because the start and end time are too close together. The other should successfully. Okay, so we'll go ahead and create 2. Let loser workout equal workout, and we're going to initialize this to not actually initialize. So I'm going to put 10,000, whatever that adds up to, and here it's 10,000 and 2 seconds. So right here, this should not work. So I'm going to go temp workout simple if let equal loser. If let temp workout equal loser workout, and we're gonna print temp workout dot end time. Let's start with start time, and we're also gonna print temp workout dot end time. And this should really not initialize, and it didn't, because it's a loser workout. It's 2 seconds apart, so it didn't initialize because clearly was done by accident. However, we're gonna create a winner workout, and that's of type workout, and we're gonna initialize this at 10,000, but the end time is of 12,000, so 2,000 second workout, whatever that adds up to in minutes. If let temp workout 2 equals winner workout, initialize, and should initialize, and we're gonna print temp workout 2 dot start time, print temp workout 2 dot end time, and this should initialize. There we go, it did 10,000 and 12,000. Awesome, and that's really the end of it. All right, awesome. Thank you for watching and have a wonderful day.